Hey guys, this video is going to be on ALU Verilog code. So I suggest you guys to go and check the theory video on ALU so that you guys understand what I'm doing over here. Each and every module is important. Each and every line you'll understand only if you watch that video. So here I'll go about doing the Verilog code. So what did I use for this? What software did I use? It's known as EDA Playground. It's there in your Google. Just type EDA Playground. You're gonna get this. And yeah, let's start going about doing this. So this is your design module, and this is your test bench module. So yeah. So the first thing what we're gonna do is design it. So let's type your module ALU and let's put your parameters. So your parameters are going to be input, your 8-bit, your 8-bit inputs A comma B. Okay. Then your next input, your ALU select, which is of 4 bits. Okay, why do we need an ALU select? You'll understand that. Basically, your ALU select will select what type of operation you need, whether you need an AND operation or operation, arithmetic operations like add, subtract. Your ALU will decide. So yeah, so this is your ALU, and then we go about giving your output, which is again 8-bit. Yeah, so we go about doing the output. So your output is nothing but your ALU out. And your next output is going to be carry out. If you see my theoretical video, you'll find that there's an ALU out as well as your carry out, so that it can be used for your next ALU. If you cascade them, your carry out will be the carry in for the next input. So I mean for your next ALU. So that's what we need. So your carry out, we're not going to tell anything about the bit size. So your carry out, because it's going to be 1 bit, can't be anything else. You can't have like 1 0 as a carry. So yeah, so I think this is it. And let's just put your closing brackets. So here in your module, usually in your C++, if you're having like a function after your brackets, you won't put a semicolon, but in your Verilog, you're going to put. So the first thing we're going to do is your register, and I'm just going to go really slow so you guys understand what's happening. So your 8-bit register is nothing but your ALU result. So this is your ALU result, and then you're going to have your, after your ALU result, you're going to have your wire. So here you have to specify what your wire is. So here the wire we're going to specify as a 9-bit value. You'll understand that why. Okay, how do you tell whether it's 9-bit or not? So if it goes from 0 to 7, when you start counting from 0 till 7, you're going to count and it's going to end up coming as 8. So that means it's 8-bit. If you count from 0 to 8, it'll come up, you'll add up to get 9, and that means it's your 9-bit number. So your 8-bit, let's say as temp, and then we're going to assign your ALU out is equal to what? So what your ALU out is going to be equal to? Your ALU result. So this is your ALU result. And the one thing we're missing is your wire, what your wire is going to be. So we're going to put your assign temp equal to. Okay, I'm going to explain this a bit later once we get the output, because you won't understand what this is happening right now. So what we're going to do is we're going to add the 1-bit zeros of A and B. So this is your 1-bit 0 of B. Okay. So we have done with that. and I've told it's 8 bits. Okay, I mean it's 9 bits. So the ninth bit of your temp array, I'm going to take it as carryout. As carryout. So this is your ninth bit. So we have done with all of the initialization. So now we can go about using your assign, like your ALU select is there, yeah. So let's define them now. So always, okay, of at, and then you're going to put a star over here. Okay, that means you have to enter this, and then you're going to put your begin. Okay, let's put begin here itself. So let's put your case. So what is your case? Your case is going to be working on your ALU select. So this will determine what is this, module used for. So this sub module is used for your, definition of your ALU select. So your case, and remember that there is no a semicolon for your always and case. It's only there for your module. Okay, rest of your sub functions are not going to have your semicolon. So now we go about doing your case. Okay, case is done. So now your first case is going to be 4 of B. Okay, that means it's 4 bits of binary, and this is my definition of it. So here, this is your 4 bit 0000, and we're going to put a colon, not a semicolon. So we'll define what it is. So this will give your ALU result as A plus B. So this is your ALU result. It's going to give you addition. So if your ALU selects 0, 0, 0, 0, 0, that means it's going to select your addition operation. So now let's go about doing your subtraction. B 0, 0, 0, 1. Okay, put a colon, and then your ALU result is going to give A minus B. Okay, put a semicolon, and then your next one, what we have learned is, here I'll be primarily dealing only with your arithmetic add, arithmetic subtract, your AND operation and OR operation. I'm not going to be teaching about left shift and right shift, because in theory I just covered that to give you a basic understanding of what is there inside your ALU. So yeah, so your next bit is 2, which gives an ALU result of A. Okay, not A. Oh damn. And B. So this is your value. So let me just give space so you guys will have a clear view of what is happening. So now we have our OR operation. So that's the last bit, 0, 0, 1, 1, which will give you ALU of OR operation. So your OR operation is like this. Okay, you're gonna have like a cap, and then you're gonna have your B. Okay, your A small caps over here. So make sure everything is right so that you don't get an error. So once you get an error, it'll be like really, really, really hard to find the mistake. Okay, unless you're proficient in Verilog. So now that we are done with all of the definition, we are going to put your default case. So your default is ALU result. What do you want to put? Let's put it as add itself. So we'll put your default case as add, or let's put it as subtract. Let's be different here. So your subtract is done, and let's end your case, and you end your begin. Okay, that your always function, and end your module. So your design function is totally done. So now I'll move on to your test bench. Yeah, so now let's move to your test bench module. So let's go about defining the time scale. So I'm pretty sure if you guys know what time scale is, like this is the basic thing for Verilog. So that means it's going to be 1 nanosecond with a precision of 1 picosecond. So this is your precision, the second value. And let's define your test bench module. So let's define it as ALU test bench and put a semicolon. So here, if you notice that in your test bench, usually you don't give your input values like how we have given over here. We're going to you're going to define it inside the module. So let's define your inputs, your register, which is of 8 bits, sorry, which is going to be A and B. And then your next register, which is the 4-bit. So what do you think is going to be? It's going to be your ALU select. That's the only 4-bit value over here. ALU select. And then your wires. So let me mention that these are your inputs. Okay. And then these are your outputs. So it's going to be your wire values. So your wire, which is 8-bit. Okay. So that gives your ALU out. I told you, if you see over here, your ALU is of 9 bits, but here your wire is of 9 bits, but here your wire is of 8 bits. That's because I'm going to be talking only about your ALU select. Your carry is totally different. Your carry is taken care over here itself. Your 9th bit is taken care over here itself. So the rest of the 8 bits I'm going to define here. So your ALU, it's your ALU out and your carry out. Sorry, it's not caps. Wire of carry out. Okay, so let's define your integer value, okay, which is going to be used in your for loop. Let's say I, and let's start your ALU test unit. Okay, this is a submodule that you'll understand why we're using it. So unit. So you're going to define your A, B, ALU select, your ALU out, and your carry out. So these are the things you're going to define, and you'll understand why. Okay, see, so basically why we have defined this is that we are calling your ALU. Okay, you see your ALU over here in your design. So we are calling this function, okay, with A given to A, B given to B, ALU select given to ALU select, ALU out given to ALU out, and carry out given to carry out. Okay, so now let's define your initial. So when you see your test bench, your initial should be there. So your initial function, okay, let's begin it. So your initial function, let's see what is there in it. So we haven't defined your A and B value yet. Okay, when you're going to perform your addition or subtraction, whatever it is, you have to define what your A and B value is. So let's give some random number. Let's give A as, let's say, 8. Okay, so 8 hexadecimal, 8 bits of hexadecimal. Let's take a number. So let's take a number as, let's say, 05. Okay, let's take your B value, 8 bits of hexadecimal. Okay, let's take 04. Okay, so let's take your ALU select. Let's start your ALU select with 0. Let's start your ALU select as 4 bits. Why is it 4-bit? Because you've defined your ALU select as 4 bits. Okay, So we don't want to waste much of registers, that's why we're putting 8. So 4 is enough for all of these 4. Actually 2 itself is enough. In case you want to add your left shift and right shift operation, that's why I've kept a buffer of 4. So a 4 of hexadecimal of 0. Okay, so let's start your for loop. Your for loop, where I is going to be from 0, going to span until I lesser than, we have taken until 4, I think. Yeah, wait, let's see. Yeah, so 0, 1, 2, 3, 4. So I will go till 4. I plus plus. Oh, okay. Sorry, I think I put a backspace by mistake. Spans until 4. I plus plus. And then let's see. Okay, in case of Verilog, you can't put brackets. You have to always put it as begin and end. So your ALU select will get the value of ALU select plus your 1. So we want to keep incrementing your ALU select, okay? So that's what we're trying to do so that you get a clear view of each and every operation. So yeah, yeah, so ALU with your 0, I mean 1, because you want to keep incrementing and you want to see each and every ALU select how it works. So H0, 1, okay, and let's end your value. Okay, before that, if you see, if you work with this, okay, wait, I'm sorry, yeah. If you work with this, okay, you're not going to get a definite output because there's no delay, okay? So your delay is a must, okay? I'll explain this delay and timing analysis in a separate video. For now, just, understand that a delay is needed or else you won't get your output. So yeah, let's get, so we have ended. Okay, so after your end, let's put it as your end for your initial function and end module. Okay, so hopefully there are no mistakes from what I've done. Okay, let's try running it. Okay, see, so now it says syntax error in 5. Okay, so yeah, let's just take these comments out. Yeah, and let's get a clear view as to what the, yeah. So now if you see your fourth value, okay, again your register of ALU30 ALU select. Okay, so if you see the error, it's saying um what is it? Yeah, module ALU declared here is okay. So let's see, a module 4 is saying a syntax. Okay, it's saying it's invalid module item. So let's see. Yeah. So your fourth line has a space over here. So that's why I said, guys, just take care of your syntax. Your syntax will matter a lot. So let's try running it. And then we have, I think, yeah, we are done. So there's no other this thing. So now if you see you're not getting your final result, that's because we haven't chosen our tools over here. So let's choose, yeah, your Icarus Verilog and your open. Okay. So here if we see we have one syntax error, okay, that's there in design. Okay, design of 20. Okay, so what do you think this thing is? We have forgotten a colon. Okay. Anything else? 21. Yeah. Let's try running it. Okay, so there is, yeah, there's one more thing. ALU select, you can see that small s. So these are the small problems that occurs. So let's try running it. Okay, now you get an error as VCD file not found. Okay, so what you go about doing that is that basically I've searched it on Google and this is a common error. So we have to display this thing. Okay, so let's try doing it. Let's put it in right after our initial function, but our test bench name is ALUTB. Okay, and let's try running it. Yeah. So you get this as your value. So basically your A is nothing but 5, okay, and B is nothing but 4, okay. So when you have 1, your 1, when your area select is 1, what it does is your subtraction. So your 1 value is your subtraction. So it subtracts, okay, and gives 1, okay. And if you see everything else, like if for example you see your 3, if you select as 3, 5 by 4 is nothing but 1 in terms of integer. And so yes, you have built your ALU. So yeah, that's it for this video. Thank you guys. Yeah, just one more thing. I've forgot to mention that what is the reason behind this? Okay, so example, let's take this out. Okay, so yeah, let's take this out and let's run it. You'll see that your carry out is in high impedance state. Okay, so only after you add, you give this assignment of 1 bit 0 of A and 1 bit 0 of B, then only you're gonna get your carry out is low initially. So basically you're trying to define that your carry out is low at the starting, so that you know you can perform your additions well. So yeah, that's it. Thank you guys.